Okay, today's lesson is 11-4, the binomial distribution, and we are going to be applying what we learned previously with the binomial theorem. So first off, a binomial experiment is a probability experiment that satisfies the following conditions. Okay, most importantly, binomial means that we're going to have two possible outcomes. There is a fixed number of independent trials. Okay, you will have two possible outcomes, and that means it's either success or failure. You'll see as we go along each time, I'll try to highlight that. Often P represents success and Q represents failure. And please remember that if you know success, you know failure because they have to add up to 1. So you're going to be given one of them. You're going to subtract that probability from 1. If it's given to you as a percent, subtract it from 100. You got to change it to a decimal. Either way, we'll talk about it as we go through. And the random variable X is the number of successes in your N trials. And I will identify each of those numbers from you as we go through the problem. So it will not be difficult for you. Okay, so first off, the binomial probability formula that they give you in your book, or you see it in most books, looks like this. Okay, the probability of X successes, so the X is here. Okay, remember P is success and Q is failure, and Q is equal to 1 minus P. Well, y'all, this is the same thing as our cranberry rule that I just talked about. So I've written it again, okay, so you can kind of remember one formula for both applications. But what you have to remember, if you choose to use this cranberry rule, B is the probability of success and A is failure. So that is the key difference between using these letters and what we're used to versus the P and the Q. Okay, so let's go look at the examples of the problems that we'll have to do. We'll try to leave that there. Okay. At Jenny's telemarketing job, 15% of the calls that she makes to potential customers result in a sale. She makes 20 calls in a given hour. What is the probability that 5 calls result in a sale? Okay, so what you have to be able to identify, you've got to know what's the probability of success, what's the probability of failure. Okay, this is my success, this is my failure, and you have to know N is your number of trials, and R in our case is the probability that we're actually looking for. So in this particular problem, success is 0.15. Okay, and as we said before, that's our B. Then we have failure is going to be 1 minus 0.5, which is 0.85. That's my A. How many trials do I have? 20 calls in a given hour. That's my N. And then X, which is my random variable here, is 5. That's the probability of what I'm looking for. So that's my R. So in my cranberry rule, when I'm looking for the probability of 5, then I'm going to plug in my numbers. Okay, that is NCR, and then I have parentheses. This is going to be my success, and this is going to be my failure. But remember, whatever number that I have here, this is my R, that's going to be the same, and these two exponents are going to add up to 20. So if that's 5, you clearly know that's 15. But my probability of success goes over here with the 5. It is 0.15. Probability of failure is 0.85. Put that in your calculator and you get that nice little decimal. And most of the time on your in your quiz, y'all, you're going to round everything to 3 decimal places, unless it tells you otherwise. But most of the time it's 3 places. So that's how I'm going to round my answers. Okay. Always pause and check your calculator and make sure you know how to use it, y'all. That's a great way to make sure you'll be successful. Okay, so look at some more examples. I'm just going to do lots of them here. At a college, 53% of the students receive scholarships. That is my B. That's my success rate. In a random group of 9 students, that's my N. What is the probability that exactly 5 of them? That's my R. And I should have written down there, but if B, well, we'll come back to it. Okay, so what's the probability of 5 of them? Okay, exactly 5 of them receive a scholarship. So I set it up, NCR. My second parentheses is the same as my R, and that's my 0.53. And how do I get the other one? Is 1 minus 0.53, which is 0.47. Put that in your calculator, and I wrote out several and rounded it to 0.257 because some people still have trouble rounding. Okay, look at number 2, the difference. It's carrying on from the same one. Find the probability that fewer than 3 students in the class receive a scholarship. So this is still my success rate. N is still 9 students, but this is different because it's not exactly. Okay, so if it's fewer than 3 students, well, how many is fewer than 3 students? That would be 0, 1, or 2. So what you actually have to do on this one is you've got to go calculate P of 0, P of 1, and P of 2. So I set them up using my cranberry rule. Remember, the second one is success, so that's 0.53 each time. Then it's 1 minus 0.53. Then you've got to multiply each of these out. There's no quick, easy way of doing it. Punch it in your calculator, and you're going to get these numbers. And then I'm going to add them up. So the probability that fewer than 3 students in the class receive a scholarship is going to be 0.064. Okay. Number 3, calculate the probability of correctly guessing 16 questions on a 20-question multiple choice AP exam that has choices A, B, C, D for each question. So, what is what? I'm not sure if you know, but N is all my number of trials. And if I have 20 questions, that's going to be my N. I want to correctly guess 16 of them, so that's my R. So now I got to figure out my success rate. But it is going to be P of 16, okay? My success rate, well, if I have 4 choices, y'all, how many of those is right? On a multiple choice exam, only one of those is correct. So the probability of success, or B, is going to be 1 out of 4, which is 0.25, which makes A, or the probability of failure, 0.75. So when I apply my cranberry rule, okay, R was 16. My second parentheses is 16. That's my success rate of 0.25. Failure rate is 0.75. Put it in your calculator, and you get a really big decimal. So if it comes out to that, obviously I don't want you to round it to 3 places. So just write the whole thing out there. Just make sure you pay attention to the directions when you take your quiz. Okay, and one of the things about this, y'all, is to use these examples when you do your homework problems so you can see just the little things and the words that change that make the problems different. Okay, so look at this one. Calculate the probability of correctly guessing 30 questions on a 50-question multiple choice AP exam that has choices A, B, C, D, E for each question. So N is 50 total questions. R is how many I want to get right. And this time I have only one of those out of 5 is the correct answer. So B for my success rate is only going to be 0.2, and A is going to be 0.8. So again, I'm looking for P of R in this case, which is 30. And to apply my cranberry rule, that's 50, choose 30. Second parentheses is 30, and that's my success rate of 0.2. And my failure rate is 0.8. And y'all, if you have any question about this, or this might not seem so obvious, but the reason it's binomial, remember there's either success or failure, and you might be confused because it says there's 5 choices. But the deal is only one of those is correct. So every time you put down a letter, it's either right or wrong. One is right, and all the other 4 are wrong. And since there's only 2 possibilities when you put something down, right or wrong, that makes it a binomial experiment. So put all those in, and you get an even smaller number because, of course, you have more choices and more questions. Okay, 2 more problems, and we're done. So calculate the probability of correctly guessing at least 2. Okay, so again, This is the difference, at least 2. Before we had correctly guessing 30. Okay, we had correctly guessing 16. Fewer than. So if you have fewer than or more than or at least, then you're going to have to add up several possibilities. So at least 2, that means you could have 2, 3, 4, 5, 6, 7, 8, 9, 10, because 10 is in. So this is an example, y'all, where it's easier to figure out the complement of it. So at least 2 means 2, 3, 4, 5, 6, 7, 8, 9, or 10. It's easier to go, well, I'd rather go figure out the probability of 0 and 1 and subtract that from the whole thing. So at least 2 is the same as 1 minus the probability of at most 1, which I just said was the probability of 0 and the probability of 1 together. So I'm going to go find the probability of 0 and the probability of 1. These are my R values. So when I apply my cranberry rule, okay, if I get 0 right, then the second parenthesis is to the 0. If I get 1 right, the second parenthesis is to 1. So before I say it, tell me what's the probability of success? Yes, there's 4 questions, so that's 1 out of 4, which is 0.25. Probability of failure is 1 minus 0.25. So put those in the calculator. You should pause it, put it in your calculator, see if you get this number and that number, and then you add them up. Now, remember, this number right here is representing that. So to get the answer to my question, I actually have to take this and subtract it from 1. So that's going to give us 0.756 as the answer. Okay, last problem, and it's a doozy. So pay attention. A manufacturer has found 3 out of every 1,100 light bulbs are defective. How many light bulbs can you order before the probability that at least one bulb is defective reaches 75%? So, same type of problem. If I want at least 1, okay, then that means I'm going to do 1 minus the probability of 0, because that's a lot less than finding 1 all the way up to 1,100. So remember what we just did. It's what we call the complement. So that's 1 minus the probability of 0. How do I find the probability of 0? Okay, applying my cranberry rule. Then I don't know how many. That's why I got to leave the n in there. But I can still apply my cranberry rule. So it's n choose 0. And what is the probability of success? Okay. The probability of, and actually remember, I'm finding what is the probability that none of them are defective. That's what this represents. So here, 3 out of every 11 bulbs is defective, means the probability of defective is 3 out of 11. And if I subtract that from 1, then that means it's 1097 over 1100 is the probability of failure. Okay, so if I'm taking my 1 minus p of 0 and applying it, then I'm going to take this. Now, y'all, anything to the 0 power is 1. So this is a 1. N choose 0 is a 1 because that's the first number in any row of Pascal's triangle. So I'm only left with this middle factor. So that's why my formula looks like this now. So, and that has to equal 0.75. So we got to solve this problem. And that's the probability part. The rest of it is what you already learned in a previous chapter. So I'm going to isolate my part with the variable. And that means I'm going to have 1097 over 1100 raised to the n equal to 0.25. Okay. Now, you've got to remember, how do we solve a problem with a variable in the exponent? Yes, you have to take the log of both sides. So I'm going to take the log of both sides and move my exponent in front with my power rule. So I took the log both sides, moved the n in front. So I have this equation. And then I'm going to solve for n. So I'm going to divide by that log that's on the left side. So it looks like that. Put it in your calculator just like that, and you're going to get an answer of 507.61. And I can't have 0.61 light bulbs, so I'm going to round it to the nearest light bulb, and that's 508 light bulbs. Okay? And the last thing before I finish, some of y'all might want to get this number and put a decimal and then round that decimal. Okay? If you rounded that decimal and carried 0.997 throughout the problem, when you finished, you would get an answer of 461.4. And you can see that would make that 461 light bulbs, which changes the problem considerably. So I would encourage you to not do that. Leave those fractions in there. Your calculators can handle it. If not, I know ClassCalc can. So just put it in. You want to put it in your calculator just like this with the horizontal fraction bar to make sure you get that same number. Okay, so that ends 11.4, our binomial distribution. Please don't hesitate to email me or come see me or set up a Google Meet if you have any questions. Thank you so much, and y'all have a great day.